Part dos.
Yes, piecewise graphs. So you've seen these in Algebra 2. They may or may not have clicked fully, and so here's your chance to actually understand them for real, for real.
They're going to come back next year, so for real is important.
Yes.
Now, this could be a situation where it's possible you don't understand everything we're saying, but you need to follow the steps that we show you today, and understanding will click in later, I promise.
Yeah.
Wouldn't you agree?
I agree. So a piecewise defined function is a function that is made up of more than one function. Little typo there, more than one function. These functions...
Obviously, Mrs. Stevenson did
Obviously
these notes.
I did, because otherwise they look perfect.
Yes.
Okay, these functions are restricted to a certain part of the domain of the overall function. So here is an example on your paper of a piecewise defined function. So we've got a function x, but that function we're only going to use when x is greater than or equal to 0.
Right, so...
Not negative?
Not negative. Negative numbers do not apply.
Right. And then negative x if x is less than 0. Now you can, maybe, if you're savvy, just go straight into drawing this. We're going to use a table of values
Let's
here.
do it. Let's change up colors, too, for less than zeros and greater than zeros.
Okay. Less than 0 is going to be grape. So when I plug negative 5 in, which of these two things does that apply to?
The bottom one.
The bottom one. I actually almost just screwed that up.
You
because
did.
I wasn't paying attention.
You were leaning
This
towards the
is-
top. I
yeah,
could see that.
This is the bottom one, and negative 5 is less than 0. So we'd plug it in right here and
so
say,
negative 5.
which is
Positive 5. Yep.
And that should happen all the way down here.
So negative 4, positive 4.
Uh-huh.
Negative 3, positive 3.
Uh-huh.
Negative 2, positive 2.
Uh-huh.
And negative 1, positive 1. Oh,
Yeah.
but we okay now.
Now, here's the deal. Where it switches needs to be plugged into both functions.
What?
I know. Here, when we plug in 0, we get 0. And what happens is that this is going to have an open dot on our graph.
That's right, because we can't actually include the 0 at this point. But we can get, the whole annoying game you play with your brother or sister.
Yeah, I think we talked about it last video, right?
Really
I'm not touching you. I'm not touching
close.
you. You got really close there. Okay, so that's why we need the open dot, because that will help us on our graph see like negative 0.1.
Right.
Because that is still less than 0.
Still less than 0. So is negative 0.0001.
0001. Beat ya. Okay, so let's go ahead and graph this.
0.00001.
Okay, so got this little
Those are
situation
excellent.
going.
Yep. Keep going. Good hands. Open circle. Open. Oh.
It's okay. Calm down. It's okay. And
I want to draw a straight line.
Okay, you ready for this?
Yeah. Cheating. That's
There we go.
cheating.
You didn't say I couldn't. Okay, now let's switch to the other function. Let's make this be moss, which is green.
Sounds perfect. So now, but look here.
Yeah.
This is greater
0
than
through 5.
or equal to 0, which
Right.
means that we can actually use this point. So whatever we
Right.
plug in for 0 now, that's closed.
Yes, that's closed. That's not an E there.
Is that
Closed.
elost?
Okay, so plug in 0 to x and you get 0. Plug
Right.
in 1, you get 1. 2, you get 2. 3, you get 3. 4, you get 4. 5, you get 5.
Right.
So
I like all of that so far.
now 0, 0 before was open, we're going to fill it in. And sometimes that'll happen that you'll do the first part and be like, oh, that's an open circle, but then the other function
Fills in the
actually
circle.
fills it in. So draw the rest of that.
And
for us.
sometimes it won't happen that way, and you'll have an open circle and then a closed filled-in circle in another place. So we're going to just put these points in here. 1, 1,
And quit, and then go
2,
second,
2.
x negative 1, and go down to
All right, and then so we cap this guy off with a line, and so this actual piecewise function creates a situation that looks like absolute value, perhaps.
And that's it. Actually, did you already say it asks us that? Which of the 12 basic functions is it the same as?
Son of a gun! I've got to
This is-
start reading these things.
I know, right? This is the same as just if we had written one function, y equals the absolute value of x. Rarely does that happen, though.
No, not very often.
Normally, our piecewise graphs look crazy.
Yeah, like
Like you wouldn't believe.
Yeah, I agree.
Okay. But that's it for this one. Are we done?
Okay, yeah.
We're done.
Good talk.